What's up, guys? On this video, we're going to explain the practice quiz 2.6B to 2.7. That is on graphing absolute value functions, which look like these, and also parabolas. But the parabolas we're looking at only have the a value of 1. Anyways, let's jump right in. This is a pretty easy question. We have an h of x function, and they tell us that they want us to find h of -5. There's function notation telling us to take this -5 and plug it into the x value. Remember, the inputs are the x values. So what is h of -5? You will end up with the absolute value of -5 minus 2, and that is a -7 in there. When you do -5 take away 2, that's -7, but it's still inside absolute values. And we know that the absolute value of any negative number or positive ends up being positive. So your answer is 7. Let's move on. We have here an absolute value function graphed, and they want us to identify which one it is. Let's ignore the multiple choice for a while. Let's just look at the actual graph. Now, remember, the form of an absolute value function is y equals a, absolute value, x minus h, close absolute value plus k. And remember, the a in this particular type of graph, only in absolute value functions, not in parabolas, only in absolute value functions, the a is kind of like slope on y equals mx plus b. It tells you to rise and run from your most important point, which is the vertex. And what is your vertex? It's your hk value. It comes from here, thinking opposite of what you see, and from here, taking it exactly the way it is. But in this case, we're not graphing. We're actually looking at the graph, identifying the hk, which in this case is -2, -4. Okay, so we now know that the h is -2. We're going to put that right here. And the k is -4. We're going to put that right there. So our vertex really is -2, -4. That's easy to see. Now what we need to do is take that h value and plug it right in there. Take the k value, plug it right in there. And not only that, we also need to identify the a value. Okay, what is the a value? Just look at the graph. Look at one point. How do you get from this point to any other point? I mean, you're going to go up and over. Up 1 over 1, up 1 over 1, up 1 over 1 this way. It doesn't matter. The a value is up 1 over 1. And of course, when you write your equation, you don't have to write it as 1 over 1. You could just leave it as 1, or in the multiple choice, you're probably just going to not see a number in place of a, because if there's no number, you automatically assume it's 1, which is that 1 over 1. So once again, let's rewrite our function y equals a with x minus h plus k. So we're going to put our h right there and our k right there. So our h is -2, our k is -4, and our a value is 1 over 1. So we don't even need anything in this spot right here, because 1 over 1, you could just leave it like an invisible 1 right there. So there is our equation. Y equals, let's clean it up a bit, the absolute value of x. We know that this is a plus 2, x plus 2, close absolute value. And the plus -4, the plus -4, we could just write it as a -4. There's our answer. That's what we're looking for on the multiple choice. And that is what we have right here. Moving on to number 3. Which of the following absolute values represented above? Once again, let's identify our vertex. Our vertex is -2, 0. And what is our a value? Our a value is technically from here to here, we go up 1 over 2. Or if you go in the other direction, up 1 over 2 in this direction. It doesn't really matter. The a is kind of like slope. It's going up 1 over 2. So we know our vertex, we know our a value. If we know our vertex, technically we know our h value and we know our k value. So when we plug it into y equals a absolute value of x minus h, close absolute value plus k, we'll be able to get our equation. So we could easily erase the a value of 1/2, erase the h, erase the k, and just plug them right in there, right? Maybe I shouldn't have erased. It got kind of ugly. So the a value is 1/2, the h value is -2, and the k value is 0. So let's clean this up a bit. What could we do to make it look nicer? The minus negative, we know we're going to rewrite it as plus. So what we have here is y equals 1/2 absolute value, x plus 2, close absolute value, Do I need this plus 0? Absolutely not. This is my final answer. That is right there, this option, right here. Moving on. Here is another. Once again, the vertex is the coordinate 1, 2. So technically, we know our h value, we know our k value, and the a value, the one that goes out in front, once again, let's write our form here. Here's our form, a absolute value x minus h plus k. So we know our h is 1, our k is 2, and from here to the next point, you're not going up 1 over 1, you're going down 1 over 1, right? Or down 1 over 1 in the other direction. But the bottom line is, if it's going up, it's positive. If it's going down, it is negative, and you're going down 1 over 1, which really means it's just negative 1, or technically, when you plug it in right here, it would just be a negative sign, right? So possibly this answer or possibly this answer over here, because both of those have a simple negative sign. Anyway, let's rewrite it with blank spots. Let's write our a value, this a value of negative 1 right here, and that's going to go in just as a negative sign. We're going to take our h value of 1, we're going to put it right there, which comes right here, and that's just a regular 1. And the k value is 2, you just plug it in right there, it's a regular 2. And is there anything to simplify? No, there's not. There is no minus minus to change. There is no plus negative where I could rewrite it as just a minus sign. This is your answer, which is right here, this one right here. Let's move on to number 5. Number 5, here we go. What do we have here? We have the vertex being 1, 2, which now we know our h and our k. Again, the vertex is this point up here. It's the maximum point of this V graph that's opening down. The a value is, how do you get from one point to the next point? You're going down 1 over 1, down 1 over 1, or down 1 over 1, down 1 over 1, down 1 over 1. So that is down 1 over 1, which we know is negative 1, which we know when we use our function, we're just going to plug in a negative sign. Wait a minute. This is a good example of reading instructions, how important it is to read instructions. It does not say write the absolute value function. It says just state the domain and range. Duh, I was doing too much work. Anyway, the domain, does it go to the left and to the right forever? Yes, even though it goes down and to the left forever. This one goes down to the right forever. So the domain is x equals all real numbers, and that's always going to be true. The domain of any absolute value function or parabola, they both go to the left and right forever. All domains of absolute value functions and parabolas will be all real numbers. X equals all real numbers. Now, the range is a different story. The range, we're talking about y's. Here's the y-axis. It's going either up or down. Obviously, this graph is going below this y value of 2. As a matter of fact, we already know the vertex is 1, 2, and the y value of that vertex is 2. So that's the maximum height on the y's. That's 2, and it's at 2 and below 2. So we say at 2 and below 2, that'd be less than or equal to 2. So there's the domain, there's the range, which apparently it looks like this one's it. X equals all real numbers, and less than or equal to 2, y is less than or equal to 2 is the range. So there you go. Let's move on to number 6. Number 6, again, we need to write the equation. This one's a little bit more interesting because the vertex is the coordinate 0, 1. So we need to recognize that the h value is 0, the k value is 1, and the a value is, let's see, if we compare this one to this one down here, because you're not going down 1 over 1. Notice that that line is not on the coordinate 1, 0. And it's not at a nice point there either. It's kind of in between. The next nice point you get to is right there, and I did emphasize it with like a red dot. So it's going down 1, 2 over 1, 2, 3. So negative 2/3 is the a value. Okay, a value is negative 2/3. So let's write our correct absolute value function form, and then let's rewrite that with blank spots so we could substitute our values safely. And let's simply take our a value of negative 2/3 and put it right here. Let's take our h value of 0 and put it right there. let's take our k value, which is 1, and put it right there. And now let's clean up anything that we could do. Like, do we have a minus minus that we could change to plus plus? No, but it is a minus 0. And we know that minus 0 is unnecessary. Hey, what's 12 minus 0? It's 12. What's 13 minus 0? It's 13. What's an apple minus 0? It's an apple, right? So this minus 0 is unnecessary. So let's just rewrite it. Y equals negative 2/3 x. We don't need a minus 0 plus 1. And there is your answer, which is right here. By the way, all these multiple choice functions have the g of x as its name. It's totally fine. It could be named anything. It could be named y, it could be g of x, h of x, q of x, whatever. We're good. Let's move on to number 7. Here's another one. Once again, let's jump right in and write the form that we want. And also let's identify the a value and the vertex. Start with the vertex. The vertex is this yellow dot right there, -1, +2. -1, +2, and that is, of course, our h value and our k value. And finally, the a value. What is the a value? Well, you need to think of the vertex and see what you do to get to the next point. Are you going down 1/1? Are you going up 1/1? We're going up 1/1, up 1/1. So the a value is 1/1, which we know is just 1, which we know that when we put it right here, it's unnecessary because that would say 1 times something. It would be that same something, right? So if somebody asks your age, hey, how old are you? You're not going to say, I'm 1 times 15. No, you're just going to say 15. It's unnecessary to put a 1 times out in front. Okay, that's kind of stretching it, kind of silly. But anyway, you don't need a 1 right there. So none of these are going to have a 1 right there because that shows that there's an invisible 1 times out there in the front. Okay, so let's just plug in our values. We have the a value of 1, which we know is not going to be on our final answer. It's not necessary. We have the h value of -1, and we have the k value of 2. And of course, what could we do to clean it up? Again, we said we don't need the 1. It's already, it could be invisible. It's assumed that it's there. And the minus minus could be changed to plus plus. So we have y equals, you don't need the 1, x plus 1, close absolute value plus 2. There is your answer. As you could see, when you look for the multiple choice answers, none of those match this. So this would be one of those where it's none of these. And the none of these options, they do happen on the quizzes and on the practice test. Let's move on to number 8. This is a fun one. I like it. It says find g of -5. So we're assuming that this is the g function, right? And we want to find, this is a function notation saying input the -5 into the g function to see what your answer will be. Now the thing is, you don't have a function. You have a graph. But you should know how to write the graph of this absolute value function that looks like a V that clearly has your vertex at 0, 0. So let's begin by writing the absolute value function, which is y equals a absolute value of x minus h, close absolute value plus k. So our vertex is 0, 0. That's pretty easy to do. You're going to plug in a 0 right there and a 0 right there, and that'll make things a lot easy, a lot simpler. What about the a value? The a value from one point to another, you're going up 1, 2, 3 over 1, okay? So up 1, 2, 3 over 1. So the a is really up 3 over 1, which we know is just equal to 3, okay? So let's rewrite our function. Y equals 3 over 1. I'm just going to put 3. Absolute value of x minus 0 plus 0. Now we don't need the, let me keep it in red, sorry. We don't need the minus 0 and the plus 0, so what is our simplified, my voice is going, sorry. What is my simplified absolute value function? Y equals 3 absolute value of x, close absolute value. That's it. That is my function. And you know what, to be more correct, we should label this g of x instead of y. So g of x is 3 absolute value of x. So there's my g of x function. And they want us to find g of -5. Okay, so let's focus in on this g of x function, and we want to find g of -5. Okay, one thing is to do it visually. If you go to -5, -3, 4, 5, where is your graph at? Man, it would be way up there somewhere. It's impossible to do it visually right here. Now, if I would have said, what is g of negative 1? Oh, the answer is 3. What's g of positive 1? Oh, the answer is 3. But what's g of negative 5? Man, that's going to be way up there off this graph. So I need to do it algebraically. Here's my function. Let's do it algebraically. What do we have here? We have equals 3 times the absolute value of x, and they're telling us plug in that negative 5. So we're going to plug in that negative 5 right there. So how do we do this? Well, we begin by doing the absolute value of negative 5, which is positive 5. And of course, there's a 3 in front, and that's not a 35. That's really a 3 times the answer of the absolute value of negative 5, which is 5. So we really have 3 times 5, which is 15. So final answer, what is g of negative 5? The answer is 15. If you just type that in, you should get the right answer. This is a fill-in-the-blank question. But there is a lot to do. You got to look at the graph. If you could do it visually, like what's g of negative 1? Oh, the answer is 3. What's g of negative 2 even? Maybe you could say, okay, where would it be at? It would be up here one more. It would be at 6. G of negative 2 would be 6. But if it's like g of negative 5, dang, you might as well write your equation and then substitute your input that they want you to put in, the negative 5, and then do the math, and you'll get 15 as an answer. Moving on to number 9. I guess right now is a good time to stop this video because we've been focusing in on absolute value functions, the one that look like V's, either opening up or down, kind of wide, kind of narrow, depending on the A value. And now we could move on to a second video that just focuses in on parabolas instead of absolute value functions, and specifically parabolas with the A value of 1. So this concludes the first part of the practice quiz.